Alright, hey everyone, welcome back. So today I want to talk about parent functions of an exponential growth function. Okay, so now to the right I have y equals 2 to the power x. And we're going to analyze this. We're going to go through it step by step. So here's the graph, y equals 2 to the power of x. Alright, so our x is an exponent in this case. Right, and here's the graph. Alright, so first things first. Alright, parent functions of exponentials, they are usually written as f of x is equal to b to the power x. Now f of x is y, and b could be any number greater than 1. Alright, so this is the parent function of this graph. Alright, of course I couldn't graph b to the power x because b could be anything that is greater than 1. So that's why I chose 2 to the power x. This is what we're going to analyze. Alright, so it must take on this form, b to the power x, for it to be an exponential. And of course this is an exponential because I have 2 to the power of x. I have my b, which is 2 in this case. So in this case, our b is equal to 2. Let's see, can I write that? So we have b is equal to 2 in this case. Okay, let me write this here. Now, next thing I have is, what kind of graph is this? So the type of graph that we can see. So let's analyze this. So this is a continuous function. It's continuous. I don't have any disconnects, meaning that I don't jump from one point to another like I would do a piecewise function. It's continuous. It is also one-to-one, meaning for every x I have a unique y. And then it is also, obviously, this is increasing because I'm going up. Alright, so this is an increasing function. You see that on my y-axis, right, all my y values, my graph is going towards the positive infinity for my y values as my x values are increasing. So let's observe the domain for this function. The domain for this function, or any function that takes on the b to the power of x form, is, so domain means x values. So you want to look at your x-axis. Alright, so here's your x-axis. What's happening in your x-axis? All those x-axis values are being taken into consideration. Alright, so as I go up the x value, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and as I keep going, these are all included in my graph because they all have values for y. So here I would say this is the set of all real numbers, right? And then my range, now let's take a close look at my y values. Looking at our y values, we can see that it doesn't quite touch the x-axis, alright? And I don't have any negative y values, that's for sure. So, alright, my y values, it's not including 0, but it's all the positive numbers. You see, it doesn't, so if you look right here, let me show you with this. Right, so here it is on our graph. We can see that it doesn't quite touch the y-axis, even if you were to zoom in, right? So here, if I could zoom in for a little bit. See what's happening? It doesn't quite touch it. Of course, you don't have to do this, but you can infer it. So the range of my values are going to be not including 0, but everything from there to infinity, because you see the y values go on infinity. So our range, if I were to write in an interval notation, I would write 0, not included, all the way to infinity. And infinity always has the parentheses because it's infinity. Alright, so here's my range of values. We have an asymptote in our graph. The asymptote means somewhere where the graph never touches. Looking at our graph where it doesn't quite touch, we can, so based on our observation from the range, we can see that we never quite touched x equals 0 because the x-axis is equal to x equals, I'm sorry, not x equals 0, y equals 0. Right, x-axis is basically y equals 0. It doesn't quite touch that. It never does, not even quite, never does. So our asymptote here is the x-axis, Okay, let me write that a bit neatly. I know I don't have the best handwriting. So here's the x-axis. You could write also, which is basically y is equal to 0. So that's your asymptote, and your intercept, alright, basically meaning where is our y-intercept is what I want to ask the question. Because obviously we don't have an x-intercept, never crosses the x-axis, never passes the x-axis, because I only include all positive numbers in my exponential growth function. So my y-intercept, so the thing is, for b to the power of x, or in this case we have 2 to the power of x, see, it's always going to be this number right here, what I have over here. Alright, and I can zoom in. You notice for every number raised to a power x, your y-intercept is oddly enough always going to be 0, 1. Alright, so let me write that to the side here. Alright, so our y-intercept is always going to be at 0, 1. Alright, now that's a coordinate. Alright, so we looked at graphing exponential growth. The parent function of that was b to the power of x, but the key thing was b was greater than 1. Now here, for graphing exponential decay, I have the graph of 1/2 to the power x. So first things first, what is the difference between this graph and our exponential growth graph? Well, we have the same function, f of x is equal to b to the power of x, except this time our b is in between 0 and 1. This is what differentiates it between the increasing and the decreasing, alright, decay and growth. So let's observe our graph here, 1/2 to the power of x. Well, the type of graph that this is, it's the same thing, continuous. Alright, also 1 to 1, same thing as growth, except instead of it increasing, it is now decreasing. And now our domain, just like growth, you see all my x values are included in my graph. So this is all real numbers. So this is the set of all real numbers in my x values, or my domain. And now let's look at our range. So if we look at the range of this exponential decay function, 1/2 to the power of x, we'll see that it is also all positive numbers. So all positive numbers from 0 to infinity. Again, it is not including 0 because we also have an asymptote here, where the graph, basically a line that the graph never touches, similar to our exponential growth function, and it's the same thing, the x-axis. And the x-axis is y equal to 0. And the intercept, so we also have a y-intercept here. For y-intercept, if you notice, so if I zoom in, we've got that this is also 0, 1. Okay? Okay, so let me zoom back out. Here. So our intercept is also the same thing as it was for the exponential growth function, 0, 1. Okay? So this is, again, so the exponential decay function y equals 1/2 to the power of x. This is an analysis of it, right? You see that it is a decreasing function, and we have an asymptote. So there are some similarities between the exponential growth and decay. Decay is when our b is in between 0 and 1, meaning that it's a positive rational number, right? That's less than 1. And for our the growth function, it's as long as b is greater than 1, then it's an increasing function, whereas here it's decreasing. Okay, and I hope this helped you, and thank you for watching.